Hello, we are working in Chapter 6, Section 6, Solving Systems of Linear Inequalities. We are going to be graphing each system, and I'm going to explain what each part means as we do it. So there are three things that I need to do for each inequality. I'll list them right here. The first thing, that's okay. The first thing I'm going to do is I'm going to try to find out where the boundary line is. Now the boundary line is going to be, spoiler, a line. We already know how to graph lines. We've done it. This inequality, I'm going to write the boundary line is going to be 8x plus 4y equals 12. Okay, now these are not the same, but this is the boundary line for this one. This inequality, the boundary line is y equals 1/2 x subtract 2. Now before you start thinking, well, can I always change that to that? No. This is the boundary line to this. They are not the same. This is just going to tell me where I can start drawing my inequality. Okay, but before I draw it, I have to decide, do I draw the boundary line dashed, or do I draw the boundary line solid? What do I mean by that? If the symbol is a less than or a greater than, then I'm going to draw dashed, and it's going to look like this. Now, normally we're not going to put arrows on the end of it, okay? So that's why you're not going to see arrows. How do I know if I draw a solid line? A solid line is going to look like this with no gaps. That's when the or equals is part of it, which basically means the boundary line is dashed, so all the points that are actually on the line don't count, because you can't have a number less than itself. If the boundary line is solid, that means that all the points on the line, they do count. It's kind of like if you have sports, is the boundary line, is that inbounds or out of bounds? In some sports, if your toes are on the line, that means you're out of bounds. Some sports, it actually does count. So it's kind of complicated. So that's going to tell me how to draw the boundary line. The next thing I need to do is I need to figure out which side of the boundary line, above or below. And I know sometimes we think about things in left or right. I want you to think about it in terms of above or below. Gets shaded. And I'll show you what I mean by shaded. So let's get started with the first one. The first one is in standard form. And remember how we graph in standard form. We let x equal 0. If I let x equal 0, I get 8x equals 12. Excuse me, I said x equals 0. Let's start with y equals 0. I'm sorry, I was covering up the y. I get 8x equals 12. And if I divide by 8, 12 divided by 8 is going to be 3/2. So it'll reduce to 1.5. So my x-intercept is right here, and I'm going to use green because I need two different colors here. You'll see why in a second. My x-intercept is going to be right here at 1.5. Got it? Now, if I let x equal 0, I get 4y equals 12, divide by 4, and I get y equals 3, which is right here. All right. My line is going to go through those 2 points. Before I draw the line, I need to decide if it's dashed or solid. Since that says less than or equal to, the or equal to tells me a solid line. So I'm going to try, I know I'm going to end up there. I could grab a ruler. I probably should grab a ruler. It's going to go right here and probably should have grabbed a ruler. There you go. Good enough. Now my last question is, which side above or below is going to get the shaded area? So here's what I do. I go to my inequality, and like I did in the first video, I pick some points. The first point I'm going to pick is the origin, 0, 0. 8 times 0 plus 4 times 0. 0 plus 0 equals 0. 0 is less than 12. So 0, 0 is on the correct side that I need. But I want to check by checking one of the points on the other side. You can go anywhere on the side. All of them are okay to check. All of these are okay to check. I did 0, 0 because they're easy. Now, I also like to try something that also has 0. So I'm going to try 4, 0, where x equals 4 and y equals 0. 8 times 4 is 32. 4 times 0 is 0. Is 32 less than or equal to 12? No, it's not. So that tells me, and I can check more points, but that's probably good enough for now. That tells me that on this side below is all these points are going to make this true, and on the other side, they're not going to be true. So here's how I shape. I know you don't have to use, I'm using different colors. I'll use this one for the other one. Get my Crayola markers out. You don't have to use different colors, that's fine. But I'm doing it because that helps you see a little bit better into what I'm doing. Do not color it in though. I don't want you doing that. When I draw it, just do this. Okay? So we're just kind of like doing some shading like you do like in art class when you do shading. That just tells me I'm going to be below it. That's fine. Alright, so that's the first inequality. Let's do the other one. Its boundary line is 1/2 x subtract 2. This is in slope-intercept form. The y-intercept is -2, which is right here. And my slope is 1/2. That tells me to go up 1 space, 1 unit, and to the right 2. Go up 1, to the right 2. And go down 1 and left 2. Now before I draw this line, I have to decide, is it dashed or solid? The greater than tells me that it's dashed. So all I do is I just connect the dots, but I don't draw a solid line. And notice I did not put arrows on anything, and I drew it all the way from one side to the other side. Okay, so I know where the boundary line is, and I know that this boundary line is dashed. This one is dashed. Actually, solid. And this was below. For the other one, let's figure out if I need to be above or below. So again, let's pick 0, 0, and this time I know it's in the green area, but now I need to see if it's going to be in the red area. Let's pick 0, 0. Is 0 greater than 1/2 times 0 subtract 2? 1/2 times 0 is 0. 0 subtract 2 is -2. Is 0 greater than -2? Yes, it is. Let's try a point that's on the other side. And on the other side, here's 0, 0. And I know it's confusing. Ignore the green for now. On the other side could be this point. So x equals 0, y equals -4. Is -4 greater than 1/2 times 0 subtract 2? Is is -4 greater than -2? No, it's not. So I know that I want to shade above this boundary line too. And the way that I shade it looks like this. Alright, now I have 4 areas. Actually, I have the lines I need to take care of, but I have 4 areas that are not part of the lines. I have this area, this area, this area, and this area. In this area, neither of the inequalities work. In this area right here that I only see the green, this is only 8x plus 4y is less than 12. In this area where I see the red, or I guess it's kind of pink, I don't know what the name of it is, this is only y is greater than 1/2 x subtract 2. But here's the part that's important. Over here where you see both the red and the green, this is where both of them are true. And this is where the system is true. It's where both of them are true, the overlap. All right, let's do that same thing except with a different system. So, my first inequality, the boundary line, y equals x plus 1. The slope is 1, the y-intercept is 1. So I'm going to start at the y-intercept, and I'm going to go up 1 space to the right 1 space. So it's going to look like this. And also the other direction, down 1, left 1. All stuff that we learned in chapter 5. Is it a dashed or solid line? Because it has the or equals, that means that I'm going to have a solid line. So I can connect all of these. Finally, do I shade above or below it? Let's pick a couple points. Let's pick 0, 0. Is 0 less than 0 plus 1? 0 plus 1 is 1. So is 0 less than 1? Yes, that's true. So 0, 0 works. Let's try it on the other side. That's below. Let's go above. Let's go to 0, 2. Is 2 less than 0 plus 1? No, 2 is not less than 1. So I'm going to shade below. So for the green one, and I don't know, I'll put the other one down here. Solid line, and I'm going to shade below. So it's going to look like this. All right, switch colors here. For y is greater than 2, the boundary line is y equals 2. Now what does it mean when it says y equals 2? That's the same as y equals 0 times x plus 2. The y-intercept is 2 right here, and the slope is 0. That tells me that I have a horizontal line. So it does not go up or down, it stays where it's at. So the next one is going to be here, then here, then here, all the way across. Before I draw the line though, solid or dashed. Because of the greater than without the equal part, this is going to be a dashed line. And I can make my dashed line like this. Just kind of make it obvious that it's dashed. All right, last part. Am I going to shade above or below it? So 0, 0, that's my favorite, that's below it. Is 0 greater than 2? No. So let's try something on the other side. Let's try 0, 3, where the y equals 3. Is 3 greater than 2? Yes. So this shading goes above that boundary line. And like I showed you last time, there's 4 areas. This area right here, neither one of them work. That's like where I didn't shade at all. This area where it's just green, this is only y is less than x plus 1. This area right here where it's just red is only y is greater than 2. And this little part right here, and I know there's not a lot of it on this grid. If I was on doing something else, I'd probably pick like a bigger grid. This is where both of them, sorry, I moved the paper. That's where both of them work. That's the solution. The solution is where both of them work. All right, let's try one more for this section. All right, we'll switch back to green again. The boundary line right here is going to be, I'll do green. The boundary line is going to be y equals x subtract 7. My y-intercept is -7, which actually doesn't show on my graph, but I know it's about right there, okay? And my slope is 1. So it's going to be here, 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 and here. Do I draw it with a dashed line or a solid line? Solid line. This is going to be dashed because it's greater than without the equal. This one's going to be solid, this one's going to be dashed. So let's draw those dashes between it. Kind of looks like Morse code. And do I shade above or below it? Let's pick a point. Let's pick our old friend 0, 0. Is 0 greater than 0 subtract 7? 0 subtract 7 is -7, and 0 is greater than -7, so that's true. Let's try something on the other side. And you know what? I'm going to pick this one way down here in the corner where it's 6, -6. is negative 6 greater than 6 subtract 7? 6 subtract 7 is negative 1. Negative 6 is not greater than negative 1. It's actually less than. So that one doesn't count. So I'm going to shade above this line. And that's going to be a lot of the graph, actually. At least for the window that I chose to print. All right, let's talk about the other one. 3x plus 6y is less than or equal to 12. The boundary line is going to be 3x plus 6y equals 12. This is in standard form. I'm going to let y equal 0 and find the x-intercept. 12 divided by 3 equals 4. So that's right here. Now I'm going to let x equal 0 and find the y-intercept. 12 divided by 6 is 2. That's right here. Do I have a solid or a dashed line? Before I can draw between here, I have to decide that it is a solid line because of the or equals part. So let's see if I can, I got to stand over here, let's see if I can draw this. Yeah, that's okay. And then it goes this way. Now I'm going to extend this just a little bit. I know I'm going off my graph, but I'm just going to extend that a little bit. And I'm going to extend this a little bit. That's my fault because I don't have, I should have picked a grid that went a little bit further than 6. But that's okay. You're just learning how the process works. Do I shade above the red line or below it? Let's figure it out. Now 0, 0 right here, my old friend, the origin is below it. 3 times 0, 0, 6 times 0, 0. 0 plus 0, 0. Is 0 less than 12? Yes, it is. So it looks like I'm going to shade below it. Let's try something on the other side and see if it works. Let's try 0, 6, where x equals 0 and y equals 6. So 3 times 0, 6 times 6. 0 plus 36 is 36. Is 36 less than 12? No, it's not. So I'm going to shade below it. And shading below it looks like this. So one more time, I have 4 areas. This area over here, which barely fit onto my graph, neither inequality has any points in there. This area where it's all green, only y is greater than x minus 7. This area where it's only red, this is only 3x plus 6y is less than or equal to 12. But this area right here where I see the red and the green, that's where both the points are going to make both of them true, and that's where the solution is. And again, notice that there's more points than I can ever list. The only way to do this is by drawing the graph. All right, we'll see you in the next video.